Hello, this is Justin Perrie, and welcome to the 5th iteration Part 1 video on improving non-playable characters within games. If you're new to the series, I do recommend going back and watching the previous videos. The links are located in the description bar. For this video, I'll be covering two topics: a quick recap of what's been done, and what's new to the system with a brief explanation. Before I start, I would like to mention I've created a new business called Theoretical Game Development. This project has now become part of that business. If you'd like to know more information about this project or any other projects, please visit our site at tgd.net.au. With that said, let's get started with the recap. The main task of Iteration 3 was to bring new technologies to support the NPCs within a game. So we have the UDK that acts as our game client, where all the game actors are loaded and interacted with. The Gossip Sociocultural Network, which acts as our support mechanisms for the NPCs, which runs within a Java virtual machine. At the time, there was a major problem with this setup. These two technologies could not interact with each other. This was overcome by developing a C++ dynamic link library, better known as a DLL, which handles the data conversion. Once the GSEN is created, it then proceeds to create a graphical user interface for direct input and creates a Hibernate connection to a MySQL database. Even though Iteration 4 focused on the development of new psychological features, new infrastructure changes were still made, which included the GSEN being capable of starting without an active game connection. Prior to Iteration 5, a person would need all this technology on a local system. The task of Iteration 5 was to at least limit the amount of supporting technologies, if not removing all needed by the client. This was accomplished by redistributing the technologies to a server-client architecture. Two different approaches were designed and implemented. The first approach was to break up the GSEN into its own server and client. The algorithm that handles the remote calls is the Remote Method Invocation Java library. Let's see this process in action. Here we have our remote server, which is provided by Amazon Web Services. I'll start up the server and the application will take care of itself. Once the user interface is loaded, the server is now ready for new clients. Now let's switch back to the local desktop and start up the UDK game, which in turn starts up the GSEN client, which that will connect to the server. The startup process takes a bit longer than normal, as the system needs to allow for the time to connect and then download the new data from the server. An advantage with this setup is that many of the features can be downloaded and acted upon locally, meaning that the game doesn't always have to communicate with the server to get things done. Of course, not all features can be done this way. Some features do require some sort of server interaction. An example is when we have two NPCs and they're having a conversation. This prompts a line to be drawn between the two icons. Since the GUI is on the server, a remote call is necessary, and if not handled properly, the gameplay performance is affected. The solution for these types of calls is concurrency, and the solution isn't exactly trivial, but basically I use a thread pool. The advantage is that many threads are reused for the many small remote tasks. I'm very happy with this approach. However, the player still needs to have the Java runtime environment installed on their computer. The second approach gets around this problem. Not only breaking up the GSEN, let's also break up the UDK and take advantage of its multiplayer features. Since the GSEN server is already running, I'm going to leave that as is. Next, I need to start up the UDK server, and that will connect to the GSEN server. Okay, let's start up our game clients. I must advise that both server and the client applications are running on a single machine. To me, both approaches have their advantages and disadvantages. For example, if you are designing a single player game with some networking features, then the first approach seems to be appropriate. However, if you are designing a mass multiplayer online game, then you already have the networking infrastructure, and the second approach seems to be the obvious choice. And with that said, the presentation is now concluded. Again, for more details, please visit our website. We also have a Facebook and Google Plus pages where you can post your feedback and your overall opinion. You also have the option to make comments, like the video and subscribe to the channel, and be very much appreciated. Thanks for watching.